In this video, we're going to briefly discuss what a turning point is. A turning point is, as it sounds, it's a point where a graph turns, where it changes direction. Strictly speaking, a turning point is any point on a graph where the function changes direction, either from upwards to downwards or vice versa. So let's have a look at a couple of examples. First of all, we have a quadratic function here. Now we have a turning point on here because the graph starts off by sloping downwards and then it slopes upwards. So the turning point is where it goes from sloping downwards to sloping upwards. In this case, it's that point there. So the turning point is the point -1, -4 for this function. Let's have a look at another example. This time we've not got a quadratic but a cubic, and this one starts by going up, then goes down, and then it goes back up again. So there's two turning points here, one where it goes from going up to down and one from where it goes down and then to up. So the two turning points are here, and that one has coordinates -3 and 27, and down here, which has coordinate 1 and -5. Now these two are both turning points, but they are different because one of them is when it changes from up to down and one is from down to up, and we have different names for these. The one that goes from going upwards to downwards, this one up here, is known as a local maximum, and the one at the bottom is known as a local minimum. Strictly speaking, we should always include the word local in these definitions, but sometimes they get dropped when we talk about maximums and minimums. They are both types of turning points. The reason this one is called a maximum is because it is at the highest point in the area around it. So if you look within the orange circle, within the orange oval, it's the highest point within that. So that's why it's a local maximum. For the purple one, the minimum down here, within the purple circle, it is the lowest point, so it is the minimum value within the local vicinity. So a local maximum is a turning point that's at the highest point in its vicinity, and a local minimum is a turning point that it is the lowest point within the vicinity. The important thing to note, particularly when we look back at this example, is that the maximum is not necessarily the biggest value that the graph can take, because up here the graph carries on going up and up forever. Similarly, the minimum is not necessarily the smallest value, because again the graph can keep going down and down and down forever and ever. What is important is that within the local area it is the highest or lowest value that can be taken. It's very distinctive shape, it's a bit like a hump or a bit like a U, so they're very easy to spot on the graphs. But it is vitally important that you realize that the local minimum and maximum is not necessarily the lowest or highest point of the whole graph.